Okay, so welcome to Chapter 2. And Chapter 2 is we're going to cover a lot of techniques for solving differential equations. But let me start with let's call it the best case scenario, right? When your equations are what we call separable. So instead of just introducing a bunch of theory, a bunch of definitions, theorems up front, if you don't mind, let me see if I can show you a separation of variables technique using an equation that you are very familiar with. So Newton's second law, F equals ma. Now, I wrote it backwards. You'll see there's no particular reason why I decided to write it backwards. It's just when I solved it on my paper, I wrote it this way. So you're going to have to suffer through my dyslexia, if you will. So let me introduce some terms really quickly, and then I'll start to unpack a general solution to a differential equation involving Newton's second law. So we know that our F in this equation stands for the total force on an object. M is the mass of an object. A is the acceleration due to gravity. We don't see the rest of these terms yet, but we will in just a second. But so G we're going to assume is just that gravitational constant, and we're going to assume that we're fairly near the Earth's surface. V is just going to be the initial velocity of the object. And then finally, B is going to represent a constant, which we will come back to in just a second. Okay? So let me start with, because right now we got to get this, right, F equals ma. We have to get this to look like a differential equation before we can start trying to solve the differential equation. So we know that acceleration is just the derivative of velocity with respect to time. So dv dt. So the first thing I'm going to do is I'm going to substitute dv dt in for a. So now we have m multiplied by dv dt is equal to, okay, and now let's talk a little bit about that total force on an object, right? So normally if you're near the Earth's surface, your force is roughly proportional or roughly equivalent to the weight of the object, right? So in this case, the m multiplied by g, so the mass and the acceleration due to gravity. Now, again, I am not a physicist. I've taken lots of physics classes, but I am out of practice, and I will give the full disclaimer up front that it's very possible that some of the terminology I use is out of place or something of this nature. So again, just bear with me. You do have someone with math degrees trying to teach you a concept in physics. So, of course, there's no current model that can precisely measure the force resistance, right, due to air on an object. Right, so I mean, if you drop an object, that air resistance is going to, if you were to try to model the air resistance, there's so many factors that you would have to account for, right? So like the density of the air, the velocity of the object, the shape of the object, right? So this is where that b, this constant, is going to come in, because what this constant is going to do is it's going to represent the constant measuring the air resistance of an object. So what we'll assume is that if you were to you can reasonably measure it if you knew the shape of the object and its density and all of these other factors. This would be, in other words, you would know this constant here. And then you could reasonably measure the air resistance. So what I'm going to do now is, so I've rewritten MA, and now I'm going to rewrite F. Right? Why? Because, again, I need it to look like a differential equation if I want to solve the differential equation. So in this case, we're going to rewrite F, and it's just going to be M multiplied by G minus BV. Okay, so again, just so I'm not going to dwell on this very long, but the idea is, remember, v is the initial velocity of the object. This is you trying to measure. This is just in a vacuum, no air resistance whatsoever, and this is minus the air resistance based on the factors that surround the object, and as well as what the object is made of. This is a differential equation. Okay, and we want to solve this differential equation. In fact, we want to solve this differential equation for v, the initial velocity. I try to think of a comical scenario as to, something that you could laugh at, but you could at least would give us a why behind the solution. So here's the best I could come up with. So let's assume that, a detective steps on the scene. He's interviewing a witness and a potential suspect, and it's regarding a bullet wound. All right. And the potential suspect, the victim says, "Hey, that other individual shot me in the leg with a bullet," and the potential suspect says, "No, wait, I didn't shoot that individual in the leg. I threw the bullet at him." Okay, well, if we could calculate the initial velocity, right, we could do a pretty good job of being able to tell if that bullet left the barrel of a gun, or it was thrown. Okay, of course we will assume that this individual is not Superman, not things of this nature. He's not a superhero. But nevertheless, let's go ahead, and now that you have a reason for solving for v, right, let's see how it works. So I'm now going to begin the separation of variables technique. Then I will come back and I will formally define the technique. All right. So just understand that m is a constant in this case. G is a constant. B is a constant. Okay, that's what we will assume. The mass of the object, the acceleration due to gravity, and whatever the object is made of, these are all just going to be constants. The only thing that is variable in this scenario is v and t. So how do we do this? Well, so the first thing we're going to do, and if you don't mind, I'm going to write you some notes. We are going to separate dv and dt. Right, so this is why for those that trained with nothing but y primes and y double primes and f primes and f double primes, they're never, when you get to differential equations, you see why this notation, right, this Leibniz notation is unbelievably helpful. So what we want is we're going to want, dt on one side, we're going to want dv on the other side. And the only thing we require is anything with a v has to be on the side of dv. And although there are none, but if there were any variable t's, they would have to be on the side of dt. Okay, so let's go ahead and jump right in. I'm gonna actually just multiply both sides of this differential equation by dt. Let's see what that looks like. So this dt would cancel here, so I'm just simply stuck with m dv. And that is going to be equal to mg minus bv dt. All right. Now, since I have a variable v here, this needs to be with dv before I can go to my next step. Okay? So what I'm going to do is I'm just simply going to divide, and I'm going to do everything at once. I'll just show you here. So I'm going to divide both sides by m, and I'm going to divide both sides by, so this cancels this, or my sincere apologies, I don't know why I just did that. Divide both sides by m, and then I'm going to also divide both sides by mg minus bv. Okay, so I'll see if I can do that in one swoop. So mg minus bv. All right, so some things are going to cancel here. So my m's are going to cancel here, and my mg minus bv is going to cancel there. So let's see what's left at that point. So I'm just simply left with dv for mg minus bv. And over here, I'm just simply left with dt over m. Okay, so at this stage, I have successfully separated my variables. Okay, I have separated dv with any variables v and dt with any variables t. And now what I'm going to do is I'm going to integrate both sides. And notice I'm integrating the left side with respect to v, I'm integrating the right side with respect to t. All, of course, I'm going to do that work down at the bottom, and then I'm going to erase this part, okay? So let's start with the easy one. So dt over m. Well, let me go ahead and write my integral symbols, so you know I'm about to integrate. So I can write that as the integral of m to the power of -1 with respect to t. Right? Or we can just simply, if it's better for you, it's probably better for you, just leave it as 1 over m. Okay, so in that case, if we integrate that, we're just going to be left with t over m plus c. Okay, so let me go ahead and erase what I have here, and then I'll work the left side for you. So if I integrate with respect to t, let me go ahead and record that answer. So t over m plus c. All right, and now what we're going to do is let's go ahead and focus on integrating the work of integrating dv for mg minus bv. Okay, well, what we can do, we can just simply use u substitution here. So we can let u equal that whole denominator. And now what I want to do is I want to take du. Now, just as I stated in the beginning, m is a constant, as well as g, as well as b. So this is with respect to v, right? So if I take the derivative of m, my apologies, so if I take the derivative of m times g, well, they're both constant, so that's just 0. And if I take the derivative of b being as a constant, with so negative bv with respect to v, this would just be minus b dv. All right, don't let these letters confuse you. mg, that's just, it's a constant, like 23. And bv is it's going to be a constant attached to v, so like 2v. All right? I can see you now, your eyes are, you're daydreaming. Look, if you took the derivative of 2v, don't you get negative 2, right? So you just remember if you, you're taking that derivative with respect to v, we're just bringing that v over here, as we did in all of our previous classes. So let's go ahead and write that. So du in this case is just negative b, and I'll use a different notation, dv. Okay. Well, clearly, I can now replace this whole denominator with u, but I want to be able to replace this dv with du, right? But I can't, right? I have the dv, but I don't have the negative b. So, but that's okay. It's a constant, so I can multiply and divide, right? So I can simply, I'm allowed to place a negative b here as long as I'm allowed to multiply by negative b, as long as I'm also willing to divide by negative b at the same time. Right? So this is just this is a fancy way of writing 1. Okay, so what are we left with at that point? So once now all that substitution takes place, negative 1 over b. The integral is now 1 over u du. And do you remember what the integral of 1 over u is? Say it. Go ahead. Say it. Say it out loud. What the heck did I just write, by the way? Let me try that again. 1 over b. Oh, so see how excited I was? Yeah, so if you integrate, the integral of 1 over u is just ln, right? It says ln u. So this is going to be ln of u, and I'm just going to go ahead and back substitute for u. And again, I'm going to put plus c for right now, but this is going to be the left side of that equation. So let me erase everything except that solution. So negative 1 over b ln mg minus bv. All right, so traditionally what we do is obviously whenever you integrate, you have plus c. So we would have a plus c on this side and a plus c on this side, but I don't want students to confuse, because I've seen students do that and then subtract c from both sides, and they're canceling things that they don't even know they're canceling c's when they don't even know they have a c. So we're going to be a little bit sloppy in our notation, but this is as well as what most textbooks do as well. So henceforward, are you listening to me? Henceforward, if you integrate the left side and you integrate the right side, just carry that constant of integration on the right side. That's it. Don't worry about carrying a constant of integration on both sides. All right, so we have separated the variables. Now we integrated what it was that we separated. What is our goal? Well, our goal right now is to get v by itself, right? I mean, if you have y prime and you integrate, your goal is to get y, right? So our goal is to get v. Now, how do we do such a thing? Well, I'll go ahead and walk you through this. So we're going to take this, let's get rid of this. We're going to multiply both sides by negative b. Start with one thing at a time. So if we multiply both sides by negative b, that at least will get rid of this. Let's see what it looks like now. So now we just have ln of mg minus bv. That's going to be equal to, now let's go ahead and multiply the right side by negative b. So that's negative bt over m. And I will go ahead and distribute that negative b to the constant of integration as well. All right, well, again, our goal is to get v by itself. So how are we going to do that? V is stuck inside of a natural logarithm. Well, we are going to exponentiate both sides. Right? So just like you could take log of both sides, you could take ln of both sides, you can exponentiate both sides, which is exactly what I'm going to be doing here. So we're going to exponentiate both sides of this equation. And now, the good news is e of ln of e, these are inverse operations, so all we're going to be left with is mg minus bv. And then let's go ahead and write e to the negative bt over m minus bc. Okay, so this next part is going to, I'm going to go ahead and put my parentheses so you know that that's all in parentheses. So this next part's going to take you a second to get used to. You seriously should listen to me and pay attention for just a second, because this is kind of a reverse order of the normal way that you do exponents. So normally you are used to, for example, if I say x to the power of 2 times x to the power of 3, you are good with saying x to the power of 2 plus 3. But we're going to go backwards. So imagine for a second that we have, if we have e to the power of, so what we're going to do is we're going to go the other way. So this is going to end up being e to the power of negative bt over m times e to the power of negative bc. Are you with me? Are you with me on what I just did? If you multiply like bases, you add the exponents. So if I can go from here to here, no problem, just add the exponents. We went the other way. Now, why did we go the other way? Because remember, this is a constant of integration. B is a constant. And of course, E is also a constant. So this entire factor, listen to me, all of this is about to become, now, your textbook probably uses a, but this entire factor is about to become just c, just a constant of integration. So let's go ahead and drop down what we have. So we still have mg minus bv. What I'm going to do is, since I've ran out of space, let me erase everything north of where we left off here. By the way, just as an aside, if I left that blue dot, would that annoy somebody? Would that annoy you, really? It's like when that professor leaves that, they erase the board and they leave that little dot on the board. You're sitting in your chair like, why didn't they erase that dot? Okay, I got you. Let me erase that guy. Okay, so all of this is just some unknown constant. Okay, so we're going to let that be represented by C. Now, in time, you can start to shorten the amount of steps that you need to solve this, right? You'll get good at this technique. At least I hope you get good at this technique, because this is the easiest of all the techniques to get good at. So let me now go ahead and write e to the negative pt over m. All right, so just remember that this whole thing is some constant. We don't know what it is. Okay, at this stage, this is all algebra. We just want to get v by itself, right? So all I'm gonna do is I'm gonna bring the mg to this side, and I'm gonna divide by what's left over. So I'll do it in 2 steps, just so I don't drive anyone crazy by skipping steps, or in our case, combining steps. So let's go ahead and subtract that. We'll go ahead and subtract that mg. And now I'm, in essence, just going to divide by negative b, divide by negative b. So what do we get? We get v is equal to, and I'll just go ahead and write this as mg over b, double negative there, and then minus c. I'll go ahead and write that as, I'm trying my best here. Yeah, I'm happy with what I just had. E to the negative bt over m over b. Let me just stop, reflect, make sure I haven't done anything silly. So if I divide by negative b here, so that negative and negative would make this a positive, okay? So this is a positive, I divide, so that becomes negative. And assuming that I haven't written anything silly, so there you have it. So we started off with Newton's second law, and we were able to turn it into a differential equation, which we were then able to separate. And we were then able to solve that differential equation. And what have we solved for? Well, we now have solved for the initial velocity. So back to my silly scenario that assuming that we know, the general shape and etc. of the bullet, we could probably try to figure out the effect of air resistance. We know weight, we know gravity, we know a lot of this information. We should be able to figure out the initial velocity of that object, and we'll be able to figure out if that individual did indeed throw the bullet or shoot the bullet. Okay, so we're going to drag out 2-1 for a while, so settle in. And we will be back for part B. We'll just probably do one more just to get our hands dirty, and then we'll just introduce the theory of it. But I will see you in the next video.